Hello everyone, let's look at best time to buy and sell stock number 2. If you did not watch the first question for this series, feel free to have a look at it first. The question number is 1 to 1. Back to this question, the problem statement is we are given an array. The ith element is a price for a given stock on day I, and we want to find the maximum profit. And we can complete as many transactions as we want. But we must sell everything before we buy it again. Let us look at the first example. The input is 715364. The output is 7. So we can buy on day 2 at price 1 and sell on day 3 at price 5. The profit is 4. And then buy on day 4 at price 3 and sell on day 5 at price 6. The profit is 3. We're adding them together, the profit is 7. In general, there are two ways to solve this problem, using dynamic programming or greedy. I will explain dynamic programming first. As usual, we need to maintain our memoization array or DP array. For any day, we can either have stock or have cash. So we can claim two memoization arrays. We can call them cash array or stock array. So our cash array and stock array. If we have cash at day I, what would be the profit for day I? It will either be we don't do any transaction, so the profit depends on the cash balance from day I minus 1. Or we sell what we have and cash in. That's stock I minus 1 and plus today's price. Really depends on which one is bigger. What about if we hold stock? At day I, what's the value? So same thing, either we do not do any transaction, that's stock I minus 1. Or we buy in, that's cash minus 1 minus price I. Depends on which one is bigger. And in the end, we want to return cash, prices.length minus 1. What would be the initial value? I guess for day 1, the cash will be 0, and for stock, it will be minus prices 0. Let's look at it again. We have cash array and stock array. Cash array refers to the profit if we hold cash from day 1 to the end. Stock array refers to the profit if we hold stock from day 1 to end. And for any day I, we update the cash array and stock array individually, depends on previous day's condition. And in the end, we return cash length minus 1. Let's look at the code implementation. And then we can do our for loop and update individual cash I and stock I. And in the end, we can return cash, prices.length minus 1. Before we submit, let's do a length check for prices. So if the length for prices is 0 or 1, so the profit will be 0. And let's submit. It passed. Let's look at the complexity. For space, it's n because our cache array and stock array, the length will be the price.length. And then let's look at time. It's still on because we have this for loop once. To optimize the space, we can simplify the cache array and stock array to make it one variable because we only depend on the previous value. We never depend on the value before the previous one. So we can optimize this and make them as 2 variables. But I will leave like this. Let's also look at the greedy solution. For greedy solution, we don't even need to concern when to buy and sell. Today we hold cash or we do transaction. As long as the price goes up compared to the previous day, we just sell and take profit in because we can do as many transactions as we want. Let's look at the code. We can remove this, remove this, remove this. We still have this length check, and this is our profit. So as long as price goes up, we just sell. And in the end, we return profit. Let's remove this. Let us submit. It looks good. Let us look at the complexity here. For space, it's constant. For time, it's on because we have one for loop. If you have any questions, please leave a comment below. Thank you for watching.